The first thing to be aware of is that there's a difference between analog audio over an Ethernet cable, digital audio over an Ethernet cable, and digital audio over an IP network. You can send 4 channels of analog audio over an Ethernet cable if you use each of the 4 pairs of wires. It's basically a very affordable 4-channel analog audio snake. When you move to a digital protocol like AES-50, you can convert the analog audio to digital, and you're able to send dozens of channels of audio between 2 devices. This is a point-to-point connection. But when you send audio over an IP network, like the one in an office building, a school, a house, or a studio, it opens the doors to much more flexible routing and monitoring. Using an audio over IP solution, devices are connected to a common network, able to route audio to and from other devices, assuming you have an audio over IP protocol that's capable of doing that. One such protocol is Dante. A Dante system may be a very large system with many different audio and video devices throughout a building tying together in a network closet, or it may be a relatively small live sound system, featuring only a console and a couple of stage boxes. One of the main strengths of audio over IP is that it's much more scalable. You can add on a device by simply connecting it to a network with a single cable, or 2 cables for redundancy. When a Dante device is connected to a network, all Dante devices on the network automatically elect a master clock source. And once those devices are locked in, which takes only a moment, you're able to send audio throughout the network by simply selecting a crosspoint within the free Dante controller software. The transmissions can now be one-to-one using unicast, or they can be one-to-many using multicast. It may take you a moment to understand the power of this if you're just getting used to the idea of audio over IP, but once you've had a chance to design and use a few of these systems, you'll see just how powerful and relatively inexpensive audio over IP can be. The setup is pretty simple. However, there are a few basic concepts that you'll want to be aware of should you be working with an audio over IP solution. It's essential to become familiar with IP addresses. Think of the IP address as a phone number of a device, a number that devices on your local area network, or LAN, will use to communicate with other devices on the LAN. Most audio systems you'll encounter will operate solely on the local area network, like I've shown here on this diagram, where each device is connected to a switch on the LAN, and through that switch, they communicate. Let's say we have some inputs on stage, a pair of powered speakers, and a mixer. The mixer has Dante built in, so we can connect it directly to the network switch. Meanwhile, the inputs on stage and the powered speaker only have analog audio connections. So to connect the microphones to the network, we can use a stage box with Dante connections. And to connect the powered speakers to the network, we can use one of these Dante AVIO analog output adapters. The analog audio inputs and outputs connect to the Dante devices with XLR cables, and the Dante devices connect to the network switch. In some cases, we could just connect the mixer directly to the stage box, but for the sake of understanding how the system works, let's use a standalone network switch. And let's also connect a laptop to the switch and open up the free Dante controller software. We can see in Dante controller, each device now has an IP address. I won't go into binary math here, but just know that each field in an IP address can range from 0 to 255, a total of 256 values, represented by 8 bits, which are either 0 or 1. All zeros equals 0, all ones equals 255, and every other combination of zeros and ones represents a number between 0 and 255. Notice that all of these IP addresses have the same values in the first 3 fields. 192.168.50.x. In order to understand why this is the case, let's start with the question, where does an IP address come from? In this case, both my computer and the Dante devices are set to obtain an IP address automatically. What does that mean exactly? There's a DHCP server on my network, which automatically assigns an IP address and a subnet mask to each device. With the first 3 fields of the subnet mask being 255 and the last being 0, each device will be assigned an IP address within the range of 192.168.50.blank. The first IP address is reserved, so this means we can have up to 254 hosts in this subnet. It also means that devices with a 255.255.255.0 subnet mask can only communicate with devices within this subnet, where the first 3 fields of the IP are these values. This setup is probably pretty similar to the setup you've got going on your home network or your corporate network. The DHCP server is most likely built into your Wi-Fi router. But what if you don't have a DHCP server on your network? In this case, each device looks for a DHCP server on the network to assign it IP addresses, but when they realize there's no DHCP server, they stick to what's called a link local address. These IP addresses are in the range of 169.254.blank.blank with a subnet mask of 255.255.0.0. This subnet allows for a total of 65,534 total hosts because the extra field that's available within this subnet adds more potential combinations. If you don't want to use a DHCP server or link local to automatically set IP addresses, you can choose to manually set a static IP address. But the same basic rules apply. You need to ensure that each Dante device and the Dante controller computer are given unique IP addresses on a compatible subnet. Again, there's a lot more to this than I've shared with you here, but these are the core concepts that I've found to be most helpful to understand. And I think they'll cover you in 80% of the situations you'll find yourself in as an audio engineer. Go on to the Dante Level 1 and 2 certifications linked below if you wish to go deeper into these subjects.